example 10.40. So it says a hollow thin-walled sphere. Okay, so I know my moment of inertia is 2/3 mr squared. I looked that up on my table. It has a mass of 12 kilograms and a diameter of 48 centimeters. So I know the mass. I'm going to go ahead and get the radius. I'm going to put meters on that just to make sure. That's in meters. The angle in radians through which it turns as a function of time is given as this equation. And they want me to go ahead and find the angular momentum and the torque at 3 seconds. So in order to do this, angular momentum, L, is equal to I omega. So in order to find the angular momentum at 3 seconds, I'm going to need to know the moment of inertia at 3 seconds and the omega at 3 seconds. Well, the moment of inertia isn't changing with time, but I will need to know the omega. Well, if they give me a position function or an angular position function, I'm going to need to find the angular velocity. And so I'm going to go ahead and take the derivative here. So I end up with 4.4 t cubed. All right, so next I need to just plug in 3 and see what we get. So my moment of inertia is going to be 2/3 times my mass, which was 12, times my radius, 0.24 squared, all times my omega evaluated at 3 seconds, times 3 cubed. All of that comes out to 58.9. Now my units for this, we got kilograms, we got meters squared. So I got kilograms, meters squared, and then I have radians per second. So whenever I see a meter like that, the second or the radian drops out, and so I just get the per second from that. All right, to find net torque, okay, well net torque I know is I times alpha. Again, I'm just going to need to find the angular acceleration at 3 seconds and multiply those two together. So the net torque is going to be my 2/3 of 12 times my 0.24 squared times my angular acceleration at 3 seconds. Well, to get that, I'm going to need to take my derivative again. So alpha is going to come out to be 3 plus, what do we get here? 13.2 t squared. Go ahead, plug that in. So I have 3 plus 13.2 times 3 squared. Getting a net torque of, comes out to 56.1, and I'll remember the units for torque are newtons times meters. You could, if you wanted to, go ahead and do kilograms, meters squared per second squared. But that's just a Newton meter is probably the better one we're going to use there. There you go.